This is a discussion on electrical conductor sizes, their corresponding nominal diameters, and the current carrying capacity. The American wire gauge, often abbreviated as AWG, is a standardized system used to denote the size or diameter of round, solid, non-ferrous, electrically conducting wire. The higher the gauge number, the smaller the wire. Conversely, a lower gauge number indicates a thicker wire. The nominal diameter refers to the approximate diameter of a conductor's cross-section. This is typically measured in inches. The current carrying capacity, also known as ampacity, is the maximum amount of electrical current a conductor can carry continuously under specified conditions without exceeding its temperature rating. Exceeding the current carrying capacity can lead to overheating, insulation damage, and potentially electrical fires. It is crucial to select the appropriate conductor size based on the anticipated current load and relevant safety standards. Here's a breakdown of common conductor sizes, their nominal diameters, and approximate current carrying capacities. Please remember that these values are for reference only and can vary depending on factors such as insulation type, ambient temperature, and installation method. Always consult the National Electrical Code or a qualified electrician for specific applications. A 14 AWG wire has a nominal diameter of approximately 0.64 inches and a current carrying capacity of around 15 amps. A 12 AWG wire has a nominal diameter of about 0.81 inches and a current carrying capacity of approximately 20 amps. A 10 AWG wire has a nominal diameter of roughly 0.102 inches and a current carrying capacity of around 30 amps. An 8 AWG wire has a nominal diameter of approximately 0.129 inches and a current carrying capacity of about 40 amps. A 6 AWG wire has a nominal diameter of around 0.163 inches and a current carrying capacity of approximately 55 amps. A 4 AWG wire has a nominal diameter of roughly 0.204 inches and a current carrying capacity of around 70 amps. A 2 AWG wire has a nominal diameter of approximately 0.258 inches and a current carrying capacity of about 95 amps. A 1 AWG wire has a nominal diameter of about 0.325 inches and a current carrying capacity of approximately 115 amps. A 1/0 AWG wire, also written as 0 AWG, has a nominal diameter of roughly 0.364 inches and a current carrying capacity of around 130 amps. A 2/0 AWG wire, also written as 0 AWG, has a nominal diameter of approximately 0.403 inches and a current carrying capacity of about 150 amps. A 3/0 AWG wire, also written as 0 AWG, has a nominal diameter of about 0.453 inches and a current carrying capacity of approximately 175 amps. A 4/0 AWG wire, also written as 0 AWG, has a nominal diameter of roughly 0.513 inches and a current carrying capacity of around 200 amps. A 250 kcmil wire has a nominal diameter of approximately 0.578 inches and a current carrying capacity of about 225 amps. Note that kcmil stands for thousands of circular mils, which is a unit of area used to measure the cross-sectional area of large conductors. A 300 kcmil wire has a nominal diameter of about 0.642 inches and a current carrying capacity of approximately 250 amps. A 350 kcmil wire has a nominal diameter of roughly 0.702 inches and a current carrying capacity of around 275 amps. A 400 kcmil wire has a nominal diameter of approximately 0.757 inches and a current carrying capacity of about 300 amps. Factors affecting current carrying capacity include firstly, insulation type. The type of insulation surrounding a conductor affects its ability to dissipate heat. Different insulation materials have different temperature ratings. Common insulation types include THHN, THWN, and XHHW, each with its own specified maximum operating temperature. Secondly, ambient temperature. Higher ambient temperatures reduce the current carrying capacity of conductors. The National Electrical Code, or NEC, provides correction factors to adjust ampacity based on ambient temperature. Thirdly, installation method. The way a conductor is installed, such as in free air, in a conduit, or buried underground, affects its ability to dissipate heat. Conductors in enclosed spaces like conduits tend to have lower ampacity ratings compared to conductors in free air. Fourthly, number of conductors in a raceway or cable. When multiple current-carrying conductors are grouped together in a raceway or cable, their combined heat can reduce the ampacity of each conductor. The NEC provides adjustment factors to account for this effect. Fifthly, voltage drop. While not directly related to ampacity, voltage drop is an important consideration when selecting conductor sizes. Voltage drop refers to the reduction in voltage along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction. The NEC recommends limiting voltage drop to 3.0% for branch circuits and 5.0% for feeders. Selecting the appropriate conductor size involves several steps. Firstly, determine the load. Calculate the total current that the conductor will be required to carry. This includes both continuous and non-continuous loads. Secondly, select the appropriate insulation type. Choose an insulation type that is suitable for the application and environment. Consider factors such as temperature rating, moisture resistance, and chemical resistance. Thirdly, determine the ambient temperature. Determine the ambient temperature in the area where the conductor will be installed. Use this value to adjust the ampacity of the conductor. Fourthly, determine the installation method. Determine how the conductor will be installed, such as in free air, in a conduit, or buried underground. Use this information to select the appropriate ampacity rating. Fifthly, apply adjustment factors. Apply any necessary adjustment factors for the number of conductors in a raceway or cable, as well as for ambient temperature. Sixthly, select the conductor size. Select a conductor size that has an ampacity equal to or greater than the adjusted load current. Seventhly, check for voltage drop. Calculate the voltage drop along the length of the conductor. If the voltage drop exceeds the recommended limits, increase the conductor size. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC provides detailed requirements for conductor sizing, including ampacity ratings, adjustment factors, and voltage drop calculations. It is essential for electricians and other electrical professionals to be familiar with the NEC and to follow its requirements when installing electrical wiring and equipment. Some common mistakes to avoid include firstly, undersizing conductors. Undersizing conductors can lead to overheating, insulation damage, and potentially electrical fires. Always select a conductor size that is large enough to carry the anticipated load current. Secondly, ignoring ambient temperature. Failing to account for ambient temperature can result in conductors overheating and failing prematurely. Always adjust the ampacity of conductors based on the ambient temperature in the area where they will be installed. Thirdly, neglecting voltage drop. Excessive voltage drop can cause equipment to malfunction and reduce its lifespan. Always check for voltage drop and increase the conductor size if necessary. Fourthly, using the wrong type of insulation. Using the wrong type of insulation can result in premature failure of the conductor. Always select an insulation type that is suitable for the application and environment. Fifthly, improper installation. Improper installation can reduce the ampacity of conductors and increase the risk of electrical hazards. Always follow the manufacturer's instructions and the requirements of the NEC when installing electrical wiring and equipment. To summarize, selecting the correct conductor size is essential for ensuring the safe and reliable operation of electrical systems. Consider all relevant factors, including load current, insulation type, ambient temperature, installation method, and voltage drop. Always consult the NEC and a qualified electrician for specific applications. Remember that the information provided is for general guidance only and should not be used as a substitute for professional advice. Always consult with a licensed electrician when determining the appropriate conductor size for your specific application. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others.